So video 4 is the first video we're going to talk about factoring. Factoring is the opposite of multiplying. It's unmultiplying. So for example, 2 times 5 is 10. But if I asked you to factor 10, you would have to tell me 2 times 5. And we've done this a little bit because we've done factor trees. We've done factor tree of 60s, 6 times 10, those are factors. 6 has 2 times 3, those are factors of 6. 2 times 5 are factors of 10. And that means 2, 3, 2, and 5, or in order, 2, 2, 3, and 5, were considered our prime factors of 60. Because those are all prime numbers, meaning they're only factors of these numbers are 1 in itself. 1 times 2 is the only way I can factor 2. Okay, 1 times 3, 1 times 5. Those are considered prime numbers. This is a skill we're going to need to know again as we look at factoring out a GCF. GCF stands for greatest common factor. So, first part of this video is going to be identifying a GCF. We have two terms here. So, similar to what we did with square roots, we need to factor tree everything. And we're going to get down to prime factors. But we have to treat these as completely separate problems. I have an addition sign in between my terms. That separates this into two separate sections. I need to factor tree them separately, so I'm going to start by doing a factor tree for this. Well, again, now I have a number and a variable. Treat them separately. Do the factor tree for the number. 14 is 2 times 7. Those are both prime, so I'm done factor treeing 14. For the variables, you just have to write out whatever x to the fourth means in longhand or in multiplication. X to the fourth means x times x times x times x, 4 x's. Now I'm done with everything here. Moving on to 21x squared. Factor tree 21. That's 3 times 7. Those are both prime. I can move to my variable. That's x times x. So that's kind of where our similarities with square roots ends. The first part is similar as far as factor treeing. That's where everything ends. Now what I need to do is find what do these two separate terms have in common. That's what GCF stands for. Common factors. So I'm looking for some number and variable that they both share. As I look here, I see this has a 7 and this has a 7. I'm going to circle them so I know I'm using them. That's one of the parts of these terms, one factor that's in common. But then I look and I can say, wait a minute, they both have an x. That's another factor that's in common, and they both have a second x. That's another factor they have in common. All of these are my common factors. I'm going to multiply them together to get my greatest common factor, 7x squared. Okay. You can see there's a 3 is the only other factor left here. There's no 3 here. That's not in common. The 2 is not a common factor. These two x's are not common factors, so the only common factors were these 3. Multiply them together, there's my GCF. Okay. Now, the only difference here is that I have 3 terms. I still have to do the same thing. I have to factor tree everything. Okay, sometimes it might be helpful to factor tree them off on the side. So here's my 10. Well, that's 2 times 5. Okay, so those are my only factors. 2 times 5, and then I have 6 x's. 1, 2, 3, 4, 5, 6 x's. If I multiplied everything here, I'd get back to 10 x to the 6th. Middle term, I have 24 x to the 3rd. Well, I know it's going to be x times x times x, but I have to factor tree the 24. So that's 6 times 4, that's 2 times 3, that's 2 times 2. Now when I go up here, just to keep this all organized, I have my factor tree off on the side or down below. I have a 2 times 2 times 2 times 3. All of these factors, every prime factor should go back up here. I should be able to multiply all of this together to get back to 24x to the third. In my last one, 2 is already prime. I don't have to factor tree that, but I have to list it. And then I have x to the fifth. X times x times x times x times x. So, what are my common factors? They each, all three, have to have it in common. All three sections here have a 2. That's a common factor. All three sections have that x, common factor. All three sections have a second x, common factor. All three sections have a third x, common factor. But that's it. Because if I look here, 5, there's no 5, not common. X, there's no x, not common. Even though it's common between the first and the last, it doesn't count unless it's common among all sections in the polynomial. So to get my greatest common factor, I multiply all of my common factors. 2 times x times x times x is 2x to the third. That's my greatest common factor. Alright, so finding the greatest common factor is only one part of this. The second part is actually to write this in factored form. It's just like we talked about, when we have 10, I want to write this as 2 times 5. Well, finding the greatest common factor helps me find the first part of my simplified form. It's what's left over that's going to give me the second part. So doing this one together, again, it's 3 terms. Now, notice I'm circling my addition or subtraction signs. There's a major reason for that, and it's going to become evident here soon. So I also put this line in now. Because what we're going to do, after we factor our 12, that's 2 times 3, and then I have 5 x's. Factor tree my 6, that's 2 times 3, and then I have 4 x's. Factor tree my 60, oh, I don't know, so let's factor tree that. 6 times 10, that's 2 times 3 times 2 times 5. So I have 2 2's, a 3, and a 5, and then I have 2 x's. I'm going to find my GCF. What's in common? 2, 2, and 2. 2, no 2 here, so I got to move. 3, 3, and 3. So my common factors right now are a 2 and a 3. I also have an x in each of them, a second x in each of them. So I can bring 2 x's. These give me my greatest common factor. 2 times 3 is 6. X times x is x squared. So that's what we had just done on the first page. But now what we also have to focus on is what's left over. Well, once I pull out my 2 and my 3 and my x, what's left over in my first term? There's a 2. X times x times x is x to the third. What's left over in my second term? No numbers, just 2 x's. That's x to the second. And what's left over in my last term? A 2 and a 5. We have to multiply. This is all multiplication. 2 times 5 is 10. That's what I'm not using. But when I write it down, I also need to separate them with my addition or subtraction signs. So I'm going to write this down as 2x to the third plus, since there's an addition sign there, x squared minus, since that was separated by subtraction, 10. Those are the key pieces of information. That's not my answer. My answer would be here, writing it in factored form. That takes your GCF and writes it first. Probably better to write it correct. Times, in parentheses, 2x to the third plus x squared minus 10. If I distribute now, I get right back to 12x to the fifth plus 6x to the fourth minus 60x squared. 6 times 2 is 12, x to the second times x to the third is x to the fifth. 6 times 1 is 6. X to the second is x to the fourth. 6 times negative 10 is minus 60, and I have my x squared. That's factored form. So let's do one more, and we'll do it together. And we're going to cut out that piece here, so I'm kind of pulling away some of the scaffolding. Here's an addition sign, factors, addition sign, factors. Organization will be extraordinarily important here. 5 is prime, so I'm just going to list the 5, and then I have 3 s's. 1, 2, 3. 30 is not prime, so I'm going to come down here and factor tree it. 3 times 10, that's 3. 2 times 5. So 2 times 3 times 5, and I have 2 s's. 40 is not prime, factor tree. 4 times 10, 2 times 2 times 2 times 5. 2 times 2 times 2 times 5 with 1 s. Common factors. I look at the numbers first, they share a 5. Then I look at the variables, they share an s. So now I'm going to focus on just one of these. What did I circle? A 5 and an s. That's my GCF. That gets listed first. Okay. What's left over? S times s is s squared. 2 times 3 times s is 6s. 2 times 2 is 4. Times 2 is 8. Both of these are separated by addition, so it becomes s squared plus 6s plus 8. If I distribute this out, I get back to my original. I'm correct.